Hello everyone, welcome to the class on basics of electrical and electronics engineering, and in today's class we are going to deal with the behavior of AC in different circuits, and specifically we are going to go through some problems in this particular video. And by the end of this course you will be able to analyze AC circuits with resistive, inductive and capacitive loads. That is our course outcome 2. And we can just go through the problem. A series RC circuit takes a power of 7000 watt when it is connected to a 200 volt 50 hertz supply. The voltage across the resistor is 130 volt, and you have to find out the resistance, current, power factor, capacitance, impedance, equation for instantaneous value of voltage and current. And I'll just write down the given data over here. So you have the power taken or consumed by the circuit is given by 7000 watt, and you are having a voltage of 200 volt. Now since nothing is mentioned, the voltage that is given will be the RMS voltage. So VRMS is equal to 200 volt, and the frequency F is 50. So you have 50 hertz frequency, and voltage across the resistor, you can represent it as VR, that is going to be 130 volt. So we can just solve the first part. In the first part you have to find out the resistance. So in order to find out the resistance, you are given a power and you are given two voltages. So how can you relate the voltage with the power? So you already know the equation for power is V square by R. Now you can see here you are having a RMS voltage as well as a voltage across the resistor. Now the power that is consumed is usually considered as that of the power consumed by the resistor. So the voltage that you have to consider over here is VR square divided by R. So using this equation you can find out the value of resistance, that will be R is equal to VR square by P. So you will get it as 130 square divided by 7000, and you will get the value of resistance is equal to, on solving you will get it as 2.414 ohms. So you have got the value of the resistance. Next we have to find out the current. So since it's a series RC circuit, so you know that this is a series circuit. You are having a resistor, it's already mentioned over here, it's a series RC circuit. So the resistor and capacitor are connected in series to a voltage source. You are having R, C, and this is your AC voltage. So if you want to find out the current, you can simply see that the current through the resistor as well as the capacitor is the same. And you can find out the current. Again, you look at the given data, you are having power, voltages, and you also have found out the value of resistance. So you know that the equation for power is P is equal to I square into R. So here, since it's the same current flowing throughout, the RMS current will be the current that you can consider over here. Okay. So the RMS current, you can find it out. You already know the value of resistance. So IRMS will be square is equal to P by R. So that will be 7000 divided by 2.414. And from this you can get IRMS is equal to root of 7000 divided by 2.414, and on solving you will get the current as 53.84 amperes. So you have got the value of the current. Now in the next part you need to find out the power factor. So to find out the power factor, again the power factor is given by cos phi, right? So you are already familiar, power factor is given by cos phi, and cos phi, you know three equations from the impedance triangle. The equation for cos phi is R by Z. Then from the power triangle, the equation for cos phi is P by S, and from the voltage triangle the equation is VR divided by VRMS. So these are the equations for cos phi, and you just look at the data that you have. So already they have given you the value of VR and they have given you the value of VRMS. So directly you can substitute the values of VR and VRMS. So it will be 130 divided by 200, and you will get the value of cos phi as 0.65. Now the power factor can be either leading or lagging, and since it is a capacitive circuit, the power factor is going to be leading. Next you need to find out the value of the capacitance. So now finding out the capacitance in this particular problem, it's a bit complicated. So the equation for capacitance that you are familiar with is, we are going to do the fourth section. The only place where you are seeing the value of C is in the capacitive reactance, that is Xc is equal to 1 by 2 pi Fc. But the problem is we don't know the value of Xc. Now, if you are looking at this particular circuit, you can see you are already given voltage across the resistor, right? You are already given this particular voltage VR, and you know the RMS voltage. Okay, so you can find out the voltage across the capacitance. Okay, if you find out the voltage across the capacitance, I can relate the I can rewrite. Okay, so you can find out the voltage across the capacitance if you know VRMS and VR. And apart from that, VRMS can also be calculated. You see this current flowing over here is IRMS. So voltage across the capacitor will be C into IRMS. So if I am in order to get the value of XC, if I write the equation VC is equal to IRMS into XC. If I can find out VC, then I can find out XC and then I can find out C. So how can I find out VC? Okay, how can I find out VC? Again, I had mentioned over here, you already know VRMS and VR. So you can draw the voltage triangle for the circuit. So this is VRMS and this is VC and this is VR. So using the Pythagoras theorem, you can find out VRMS square is equal to VC square plus VR square. So if you are doing a back work, first and foremost you have to find out VC. Once you find out VC, you can find out XC from the voltage drop equation. Then once you find out XC, you can find out the value of the capacitance. So first and foremost, what we are going to do is that using the equation we got from the voltage triangle, you find out VC, that is VRMS square is equal to VR square plus VC square. So from this you will get VC is equal to root of, you take this to the VR square to the other side, you will get VRMS square minus VR square. So if you just do the substitutions, you will get the value, that is root of 200 square minus 130 square, and you will get the value of VC as, on solving you will get the value of VC as 151.98 volt. So I had mentioned, once you find out the value of VC, you can find out the value of XC. So our equation is VC is equal to I into XC. So from this you can find out XC is equal to, here it is IRMS, VC divided by IRMS. So that will be 151.98 divided by 53.84, and you will get the value of XC as 2.822 ohms. And once you get the value of Xc, you can find out the value of capacitance, Xc equal to 1 by 2 pi Fc. So from this you will get the value of capacitance, C is equal to 1 by 2 pi F into Xc. And on solving, 1 by 2 pi into 50 into Xc, you have already got 2.822. You will get the value as 0.00112 farad. So you have got the value of capacitance. And the next part, so you have found out the resistance, you have got the current, power factor, and the tough one was the capacitance. How can you find out the impedance? So you already know the equation, so I'll just split this page into two. You already know the equation for impedance. Z is equal to R plus J into XL minus XC, but here there is no inductance, so you have only XC. So it is actually minus since it's only a capacitance, and we just need the magnitude over here. So you can find out, the fifth part, R square plus XC square. This is the magnitude, so R square plus XC square will give you Z. You have already found out the value of resistance, that is 2.414 square, plus the value of reactance is 2.822. Please note, many students make the mistake of substituting the value of capacitance. You should not take the value of capacitance, you should take the value of the capacitive reactance. And on solving, you will get the value of Z as 3.713 ohms. And the last part of the section, you have to find out the value of instantaneous value or equation for the instantaneous value of voltage and current. So the general equation for voltage is V is equal to Vm sine omega t. Okay, that's the general equation for voltage. Usually we are taking voltage as the reference, that is why the equation is like this. And the general equation for current is I is equal to Im sine omega t plus or minus phi. Okay, so you're going to give the positive sign if you are having a capacitor in your circuit, and you will give a negative sign if it is having a inductor, or in other words, if this is leading, it's going to be positive, and it's going to be negative if it is lagging. Right. So this is my general equation for instantaneous value of voltage and current. If I can find out Vm, Im, omega and phi, I can just substitute it and you will get the equation for the instantaneous values. So how can you find out the value of Vm? You already know the value of RMS voltage, and you know the relationship between RMS value and maximum value in the case of a sine wave. So in the case of a sine wave, Vrms is equal to Vm divided by root 2. So from this I can say Vm is equal to Vrms into root 2. And on substituting, 200 into root 2 will give you, I'll just check the value. Yes, on calculating you will get it as 282.84 volt. And as you have written the equation for the voltage, you can also write a similar equation for current. Im is equal to Irms into root 2. You have already found out the value of Irms. In the second part, you have found out the value 53.84. So 53.84 into root 2, and you will get the value of Irms as 76.14 ampere. So I have got the value of Vm and Im. Next I need to find out the value of omega. So I will just continue it over here itself. Omega is equal to, this is the angular frequency, and you have already been given the equation value of frequency in hertz. So omega is equal to 2 pi into f radian per second. So you have 2 pi into 50, and on solving you will get it as 314.15 radians per second. Right, so you need to give the value of angular frequency. And the last one, if you get the value of phi, this problem is over. So you already know, where have you seen phi? When you are finding out the power factor is given by cos phi. So from the cos phi, you can find out the value of phi. So here you have cos phi is equal to, what is the value? 0.65. So from this, you can find out the value of phi. Phi will be equal to cos inverse 0.65, and you will get the value of phi as 49.45 degrees. 49.45 degrees, but you see over here the value of omega is in radians per second, and because of that the value of phi should also be in radians, and you can use your calculator to convert the degree into radians, and you can get the value as 0.863 radians. You can just do the conversion in your calculator. And finally, you just rewrite the equations. You have already got the equation for instantaneous voltage and current. So instantaneous voltage V is equal to Vm, that is 282.84 sine, value of omega is 314.15, and you give the time as it is. And if you want to find the instantaneous value of current, I is equal to, Im is 76.14 sine 314.15 t, okay, sine omega t, and since you are having a leading circuit, you give it as plus 0.863, that's the value of phi. So this is the equation for the instantaneous value of voltage and current. So we can just recap what we have studied over here. From the equation for power, V square by R, you have to take the voltage across resistance. Everyone makes a mistake over here. Don't take RMS voltage, take the voltage across the resistor. So using P is equal to V square by R, you can find out the value of resistance. Using the equation P is equal to IRMS square into R, you can find out the value of current. Then the power factor from the voltage triangle or the power triangle or impedance triangle. Here in this case, we are using the equation from the voltage triangle. Then to find out the capacitance, first we found out the capacitor voltage from the voltage triangle. Then you found out the value of XC, that is the capacitive reactance. Then from the value of XC, you found out the value of the capacitance. So these steps are given over here. Then to find out the value of impedance, Z is equal to R plus J into XL minus XC. Here the value of XL is 0, so it is R minus JXC. And you find out the magnitude, so Z is equal to root of real square plus imaginary square. And then finally we found out the value of instantaneous voltage and current equations. And you found out Vm by using the relationship for a sine wave, Vrms is equal to Vm by root 2. Similarly, you can find out the value of Im. In order to find out phi, you take the equation for power factor and find out the value of phi. So you try out more problems from the textbooks and the previous year questions, and if you are having any doubts, you can always contact me. Okay, thank you. Please watch the video and complete your notes. Thank you.